Proceed now with the second part of today's conference, the third session under the title Technologies, Materials and Principles Put a Stress on Industry as a Core Focus of Architecture and Urbanism as Building Discipline. In this panel session, we will have the opportunity to get acquainted with specific building industry. And I will have to tell you that today in our program, we have three panelists, but unfortunately, Renata Morbiducci was not able to come to this conference. So we will have two panelists, Jelena Dragaš and Marija Šipetic-Bjegović. First of all, I will introduce them, and then please, speakers, come to the floor. Jelena Dragaš is an assistant professor of concrete structures of University in Belgrade, Faculty of Civil Engineering. The main focus of her research is in the field of concrete structures, sustainable alternatives to traditional concrete, application of waste and recycled materials in the production of concrete, high-volume fly ash concrete, geopolymer concrete, and recycled aggregate concrete. During her research, she published over 30 publications, including journal articles, book chapters, and conference papers. Mrs. Dragaš participated in 8 international and national research projects and was an invited lecturer in the Cambridge Tradition Summer School in 2019. She was awarded by the Belgrade Chamber of Commerce for one of the best PhD theses that influenced the Serbian industry in 2018. And then the second speaker, Marija Šipetic-Bjegović, an architect. She started her professional career in 2003 at the company Progress from Belgrade as a construction and technical advisor in the engineering sector. She worked as a chief engineer on several major projects in Russia and Serbia. Since 2008, she changed her professional orientation and became a part of company Alu-König-Stahl in Belgrade. Alu-König-Stahl company is the general representative of the Schuko company, a renowned German manufacturer of systems for the production of glazed curtain walls, windows, doors, and protection systems. She became a head of the technical department there, and with her team participated in the design of glazed facade constructions of famous and significant buildings in Belgrade and throughout the country. From 2022, she holds the position of a general manager in Serbia and becomes part of the management of the parent company Alu-König-Stahl GmbH as the only woman in the company for the 170-year long history. So, Jelena, thank you.
So hello, everybody. Thank you for inviting me to this conference. I'm glad that I will have a chance to discuss this eco-building problem from a different perspective from all of you. As you've heard, I'm an assistant professor in concrete structures. So most of my work is dedicated toward research of the alternatives to traditional concretes from one part, and from another side, I'm also a designer in traditional concrete structures. So that's the perspective from which I will be speaking today. So construction industry is under a great pressure to reduce its environmental effect, and it's accounted for approximately 40% of total climate change impact. And that is mostly due to a large consumption of energy and raw materials needed for its processes, but also for the production of great amount of carbon dioxide emissions and the emissions of other greenhouse gases, but also a generation of large quantities of waste. If you look at the CO2 emissions, and for example, one building, they come from all these stages of one building's life. So we calculate the total CO2 emissions from the production of all raw materials needed for building that structure, transport of those materials, the construction phase, the use of a building, and materials needed for maintenance, for repair, and other jobs, but also for the energy and water operations that are taking place in that object. And last, we also account the CO2 emissions that are accounted in the end of life and beyond end of life phase, because we are thinking about what will happen to that building after it reaches its grade, to say. So these CO2 emissions can be divided into embodied carbon, so the carbon footprint that is associated with the production of materials and transport and the production of those materials, and operational carbon, or the carbon footprint associated with, for example, heating, cooling, or other energy and water operations in those buildings. So if we look at the global annual production of CO2 emissions from all sources, around 40% comes from the construction industry, and is divided into these two, let's say, categories of carbon footprint. If we look at the different sources and different types of objects, the distribution of this carbon footprint between operational and embodied CO2 is different. Those are some estimations of those parts, but the general trend is that innovation and changes that are being made in the operational carbon footprint in the last or past couple of years are much faster compared to the changes that are being made in the production of materials. So we can assume that this total CO2 associated with construction industry can be equally divided between operational and embodied CO2 in buildings. This means that this embodied CO2 part is actually really significant, and it's mostly attributed to the production of structure or exterior and interior of buildings, with the largest part of CO2 connected actually with the production of the structural part of a building. And when we talk about the structural part, we mostly think about the mostly used construction materials like concrete, steel, aluminum, and so on. And we can, without a doubt, say that concrete is the most widely used material, construction material. So that's why the rest of this presentation will be dedicated toward concrete. But also, this is my field of expertise, so that's another thing. So you probably heard this sentence that after water, concrete is the most widely used construction material in planet, but it benefits mask enormous danger to the planet, to human health, and to culture itself, as it said in a Guardian article and many of the podcasts and other media that they have. So this is just the reflection of a really great pressure to the concrete industry to reduce its negative environmental effect. But it wouldn't be fair to look at this negative effect without acknowledging that concrete is one of the main actors that actually enabled this human development that we are facing today, the speed and the extent of that development. So it is important to look at both benefits and to recognize main problems so that we can continue forward in a sustainable manner. So what is the problem with concrete? The main problem is that it's being used in a large quantities. So there is probably not a single construction project on Earth today that is being done without the use of concrete. But if we look around, concrete is now present in many other forms. We are actually trying to produce concrete to build on Mars also. So as we can see, the future of concrete consumption will be even greater compared to today. This is really important because if we look at different materials, for example, if we compare concrete to steel or aluminum, and if we compare 1 cubic meter or 1 kilo of those materials, concrete wouldn't be the most dangerous one. For example, the production of aluminum is really energy and CO2 intensive. But concrete is used in much greater amplitudes compared to those materials, and that is why its negative effects are actually really big. Aside for a great consumption, maybe the main problems with concrete are the CO2 emissions that come mostly from cement and a great use of natural resources, natural stone, and great quantities of waste that are being generated after the end of life of all buildings. The main problem with cement is that we can approximately say that the production of 1 kilo of cement is equal to the production of 1 kilo of CO2. So the production of cement emits a large amount of CO2. And for the production of 1 square meter of concrete, we approximately need around 350 kilos of cement. So we can see that 1 cubic meter of concrete actually has a large CO2 impact. And if we know that we have a large quantities of concrete that are being used around the world, and that cement application is greater than the application of concrete. We use cement for soil stabilization. We use it to produce different types of glues, of mortars. It is not a surprise that cement itself is responsible for around 10% of total CO2 emissions globally. Where does it come from, the CO2? So if we look at this chart or scheme of the production of cement, we have two main issues. To actually produce cement, we need to heat limestone and some other materials to produce the Portland cement, the cement clinker. And during that chemical reaction, heating on really high temperatures, heating the calcium carbonate, we actually have as a result cement clinker, and we have CO2. So this chemical reaction cannot, at least now, cannot be performed without this CO2 that is being emitted in the atmosphere. And it is estimated that around 40% of the total CO2 emissions coming from cement are coming from actually energy needed to heat the limestone, and the 60% actually comes from this chemical reaction. So this is a kiln, a part of this whole process that is actually the part where this chemical reaction takes place, and this is why it is being targeted as the critical point for reducing the CO2 emissions. Aside from this, production of cement has been rising throughout the years, actually in a much faster rate compared to the population growth. And in the last 65 years, the cement production risen 34 times. That is around 10 times higher than the population on Earth. And for example, in 2015, more kilos of cement per capita globally were produced compared to the consumed food per capita in that year. So if we look at this growth, we can see that it is an exponential growth, and I'm afraid that it is not going to change anytime soon. So we have all this problem associated with cement. So there are a lot of strategies that are being implemented in order to try to reduce this negative effect. Some of them are used to reduce this chemical part, and they are mostly oriented toward actually using less amount of cement to use cement in a more efficient way, or to replace cement with some other adequate material. Or other part of these actions are oriented toward making this process of cement production more energy efficient. So one of the ways to reduce this negative effect of the production of cement, that is actually relatively simple, relatively cheap, is to use some so-called supplementary cementitious materials that are mostly byproducts from different industries to replace partially or totally cement in concrete. So the mostly used materials are fly ash as a byproduct from thermal power plants, slag as a byproduct from the production of steel, or red mud that comes in the production of aluminum. So these materials are used to partially replace cement in concrete, and they are actually one of the parts of the cement that we buy today. So when we say cement, it's not 100% Portland cement like it was when it's first introduced to the market, but now it has some percentages of these materials, with the idea to reduce the amount of cement that is being used. And another way is to completely eliminate cement, which can be done in so-called alkali activated concrete or geopolymer concrete, which is basically concrete made from one of or combination of these materials that can be activated not only by water, but by water in combination with some alkaline solutions that have really high pH. And these materials are being used now in practice, and that's one way to go from using a lot of cement to actually eliminating it. All these solutions have some problems, some obstacles. These byproducts are something that is nowadays necessary to produce cement, and unfortunately many of them are lacking now in some markets. For example, a lot of countries in Europe actually don't have enough quantities of fly ash or slag that they need for the production of cement, so they import it if needed. On the other hand, countries like Serbia have great quantities of fly ash that is not being used. It is landfilled, but the quality of that fly ash is not always really good, so it cannot be in all quantities used in concrete. So research now is oriented toward finding new alternatives to cement, because at this point there is no turning back to that 100% Portland cement. We need to find some alternative to, for example, replace fly ash or slag or something like that. And another problem, well, some would say problem, is a relatively low price of cement. Cement is a local material. Its price varies from country to country, but it's still a relatively cheap material, but it's being considered as a commodity, and it's really strictly standardized. So it's not so easy to make changes in the production of cement, which makes it really hard to introduce these innovative solutions into this project. Another way to reduce the negative effect of cement production on the environment is to reduce that 40% of CO2 part. And that is being done by making this process of the production of cement more energy efficient, and actually to replace fossil fuels with some alternative energy sources. And for example, in Serbia, most of the cement plants use incineration of municipal waste as a way to replace a part of energy source in their production. And there is one popular technology now that is being researched and tested. It is a CO2 capture and storage. So the idea is to capture the CO2 in the place where it emits in kilns, in this case, in case of cement, to transform that CO2 from gas to liquid, for example, and then to store it in containers or in another safe way, underground or underwater. So this seems like an efficient way to eliminate CO2 from the atmosphere, but this technology is currently really expensive. It is not sure, it is energy intensive, so a lot of energy is needed to transform gas to liquid. So there is still a lot of research needed for this technology to find its way into practice. And the second, let's say the biggest problem with concrete is large quantities of natural resources that are being used for the production of concrete. Approximately 3/4 of concrete waste are actually coming from stone. So large quantities of concrete actually need large quantities of stone. And that natural stone comes mostly from rivers, from riverbeds, or from quarries. And if we use that large quantity, then there is a big problem with changing the environment and affecting the microclimate and biodiversity in those regions. And one of the efficient ways to reduce the use of natural resources is the use of recycled ones. So it would be logical to use recycled concrete as a partial or total replacement for natural stone. Especially if we know that construction and demolition waste is around 30% of the total waste, and concrete is a half of that portion. And these great quantities come from a large amount of construction and demolition waste produced during the construction of buildings, during maintenance, during repair, and mostly during demolition of these objects. The research and practice already showed that it is possible to replace up to 100% of coarse aggregate in concrete with the recycled concrete aggregate. And this is being done in moderately in the application of concrete where some moderate properties are needed. So it is being mostly used in the construction of residential or commercial buildings, but it's being used also in layers of roads or other objects in the infrastructure. So how does this grain of recycled concrete aggregate look like? As you can see, it's actually a crushed concrete, and 1 grain of that recycled concrete aggregate consists of part of natural stone and part of cement mortar. So it has different properties compared to natural stone, of course. It is inferior to it. It has a lower modulus of elasticity, lower strength. It has higher porosity, creep, and shrinkage. But these inferiorities are not something that eliminates this material from practical use. It is only important to know all these properties so that recycled concrete aggregate can be adequately used. What are the obstacles here, or some of them? First of all, if we want to use recycled concrete aggregate, we need to have a place where we can buy it or obtain it. And in many countries, there is a lack of recycling strategies and markets. Here in this figure, you can see in these gray bars, the percentage of recycling of concrete in different countries. There are a lot of European or global strategies and initiatives that actually require recycling of some amount of waste, but they are not being followed in many countries. Aside from that, if we have a low price of natural stone, like we have in Serbia here, then there is not enough motivation for investors to actually use recycled concrete aggregate, because recycling can be a really expensive process, and recycled concrete aggregate can have a higher price compared to natural stone. So it is important to have a state or local strategies that motivate the use of recycling, that give subventions to recycling companies in order to make an adequate market for it. There are also some technical unknowns, but the codes and standards that we have for the design actually recognize recycled concrete aggregate and allow and explain or define the use of that material in reinforced concrete structures. But in some countries, these technical norms are not maybe developed in an adequate extent for the practice to use them easily. And like in any other recycled material, there is always a lack of trust in waste or recycled material. So places like this conference and similar are a place to break that bad chain of lack of trust. And at the end, as one of the questions that are being asked about concrete is it durable or not? It is important to know that we design concrete structures to have a certain service life. They are designed to last 50 or 100 years, depending on the type of the structure, the importance of the structure. But that doesn't mean that the structure will collapse after 50 or 100 years. It just means that in that period of time, there won't be a need for a great maintenance or reparation businesses if the structure is maintained regularly and as it should be. And during that period, the formation of cracks is something that is normal. We design the width of those cracks and we expect them to form in our structure during the service life. But if the structure is not maintained in a proper way, then durability only in that point can be something that is a problem with concrete. But nevertheless, the research is going forward and trying to make ways to find ways to make concrete even more durable, so that we reduce the amount of waste that will be made. So we are now designing structures for a specific performance that they need, and we are developing self-healing concrete with some agents, some bacteria in concrete that can actually repair those cracks after they form. So aside from those strategies for making concrete more sustainable, we also try to optimize our structures, optimize by design, by using, for example, pre-stressing, by analyzing loads in a more detailed manner. So the idea is to use as less material as possible. We are trying to make our construction site or processes more efficient. We use 3D printing technologies because 3D printing allows us to actually eliminate the formwork, and we can make really optimized shapes and structures if we use 3D printing. We have self-healing or self-sensing concrete. So we are trying from a different perspectives to make concrete as efficient as it can be, which is from one side a good strategy, but there is also we should also be careful, because efficiency strategy is not always oriented towards sustainability. And if we succeed in making concrete a really efficient material, then investors will use that material more, and maybe we will actually at the end have a higher usage of concrete when it is more efficient. And because of that, the real fundamental strategies that we need to apply to make concrete sustainable is actually to build nothing. So to try to use or repurpose the objects that we have, to build only to meet needs of the communities, because there are a lot of examples in China, for example, a lot of cities that are actually made mostly of concrete and they are completely abandoned, or a lot of structures that are not finished because of the economical crisis or something like that. So we must admit that nowadays we don't build only for the needs of the community, but for some other purpose. So building efficiently and all these strategies that I told you about are something that we need to do at the end and not at the beginning of this sustainability journey. So I think that for any material to be sustainable, we need to have a fundamental knowledge about its properties and processes related to that material, so that we can actually make specific tailor-made strategies for each project, looking from the beginning of the project, from the design to the beyond end of phase, in order to have a sustainable project and sustainable material. And in this manner, it is extremely important to have a knowledge about systematic sustainability analysis for eco-evaluation to avoid some wrong conclusions, some misleading or any other greenwashing that is being present. And in order to do so, we need to adopt adequate methodology for these analysis. And for example, if we talk about concrete and we want to compare two different types of concrete or concrete structure to structure made from a different material, we actually need to look at the structures that are made to have the same capacity, bearing capacity, the same sustainability, the same durability, and the same fire resistance for proper comparison. Only then we can actually choose the best solution for each project. Thank you for your attention.
From the past 15 years of experience in design of glass facades, let me introduce you with the potentials of glass facades for construction for ecological and green architecture. Speaking about eco-friendly, definition of what is eco-friendly, we will meet following words: reduced, minimal, or no harm to ecosystems on environment. But what is really eco-friendly and green facade construction? If we ask ordinary people from the street, they will probably have this picture in their mind or something like this. But actually, it is something much more. If we go back to the definitions of eco-friendly, green architecture, green building, we will find out several common points. No harm upon environment, using sustainable source of energy, reduce energy use, and finally, resource efficiency through the whole life of the building. Taking in consideration those points, why glass facades should be in focus for us? Because in contemporary architecture, up to 100% of facades are from glass or can be for glass. Why buildings are in our focus? Because 90% of time we are spending in the buildings. And additionally, up to 40% of all material and energy consumption is connected with the buildings. So what we, people who are designing the buildings and in like part of these buildings designing the glass facades should do, what should be our goals? Our goals should be to build 100% comfortable, safe, and energy efficient buildings, and at the same time with minimal possible use of materials or harm upon environment. Taking in consideration all what is said before, we can conclude that glass facades are 100% important potential for green and ecological and green and sustainable constructions. Thinking about this presentation, I imagine it like a small handbook for eco-friendly built glass facades. And I wanted to identify all potentials which this construction have for eco-friendly, green or sustainable construction. First area of potentials is definitely connected with the design. On the left side, you can see the list of things on which we can influence and which are connected with the green or sustainable construction. Working on the design of the facade, from the simple small one facade or part of the facade to the state-of-art technological facade solutions, we can influence of these factors. First step in designing of the facade is definitely choose the material. Material for the glass facade can include wood, steel, aluminum, PVC, concrete, and some more modern materials. With this choosing material, we can influence of following factors connected with the sustainability construction. The next step in design of the facade is definitely shaping. Shaping is something which can bring us really a lot of tools for influencing important factors for the sustainable construction. We can choose simple shapes or the most complicated parametric shapes, which of course will give us much more tools for influencing important factors. Let's go one step forward and think about greenery or greenhouses on the facade, which we can influence on some other factors. Also designing sun control or light comfort on the building, we can influence on the much more factors connected with the sustainable construction. And finally, the most complicated and the most influenced part of the designing of the facade is to choose type of the building scheme. Building scheme can be mono and multi in many ways. Speaking about mono or multi, we're speaking about layers, functions, efficiency, etc. So we can design facade like a single layer facade, which means simple curtain wall, window or door. We can design it like a double facade, closed cavity facade, cassette facade, or the most complicated type of the facade is active cavity transfer facades. Choosing the building scheme, the type of the building scheme, we can influence on much more factors connected with sustainable or green architecture. In this moment, the most complicated and the most sufficient type of the facade is active cavity transition facades. Those facades work together with the building and make an active scheme. Designing this facade, we have in designing of this facade, we have a lot of tools with which we can influence important factors, factors important for the level of green and sustainable architecture. The next group of potentials in a glass facade is definitely connected with the potentials in products. So after we finish the phase of shaping our facade, we should choose products from which we will materialize our facade. Choosing the type of the products, we are actually choosing the material and function. We can use or choose separate products which can be connected with the facade, like ventilation elements, sun or glare shading, or we can choose complicated, less or more complicated system combined from different products. first step is definitely choose the material of our products. And we can take traditional materials, wood or steel, or contemporary materials, which is today aluminum and PVC. But we should not forget new materials like fabrics, photovoltaics, dynamic glass, organic and sustainable source materials. Choosing material, we can influence on following factors connected with sustainable constructions. Next step definitely is choosing a function, products with a specific functions. Some products are referring to savings. Some products are focused on protections, different kinds of the protections. Some products are oriented to the production. We are speaking about production electricity with photovoltaic. And we have a group of products which are connected with the controlling systems. With choosing specific products, we can influence on all factors which are important for eco-friendly, green or sustainable architecture. Also, we can, choosing the products, we can choose just one product, single product with sustainable orientation, or we can choose a combination of the products or really complicated products which are together, working all together, bringing us influence on important factors for sustainability. The next group of potentials connected with the glass facade lays in a standardization and certification. If you're speaking about national standards and legislation, they're establishing politically and socially acceptable minimums. So we, like people from the practice, we should point out importance of green standards, which are establishing higher, or let's say different, level of contribution to green and sustainable architecture. In green standards, we are separated green building standards, green codes, green product certificates, and green building rating and certification systems. They can influence, and they give us tools for influence on different lists of important things connected with eco building and sustainable construction. This list consists from some new topics like ecological footprint, VOC controlling, lifetime and reuse, innovation and management. Of course, first step is to start with the product certifications. There are a lot of certificates which are referring to materials used in a glass facades. Product certificates in glass facade can refer to energy, wood products, insulation, material quality, safety, lifetime, recyclability, controlling of VOC usage, air quality, products for building operation and maintenance. Maybe the most difficult certification way is cradle-to-cradle kind of certification. This picture actually shows us what is the role model for cradle-to-cradle sustainable concepts. Cradle-to-cradle concept means exactly take material from the nature, use as less possible energy during the production, and of course decrease as much as possible emission of harming materials. Then after life cycle of some material or system is finished, material should be recycled and sent back to the nature to use in the new circle. Of course, this is really difficult, but some products from my company has this cradle-to-cradle certification. Besides the certification connected with the products, building certification and rating is really important because it's broadened the focus beyond the products to consider the projects as whole. We all know several different building certification systems like DGNB, LEED, BREEAM, OGNI. All of them include 7 common components of green building: energy efficiency, water efficiency, green sustainable materials, waste reduction, indoor air quality, community, and commissioning. Here, maybe we should stop a little bit to explain differences between sustainability and green. Sustainability is more oriented to the future and set the higher standards, or let's say, add to above mentioned list of components 3 new important components: durability, recyclability, and reusability. Certification system can give us tools with which we can influence on following factors important for the sustainable constructions. Working on the residential building, we can influence with certification on several groups of products and elements, also in a residential, in office buildings. And the final set of potentials connected with the glass facades is social responsibility, is connected with social responsibility and conscience of the participants in the process of design, producing, or installation of glass facades. Our company stands behind the 360% sustainable approach for the design to the end of the building life cycle, which means that all participants in the process of designing, production, investing of facades should be included and can be a part of, can take a part in sustainable construction. With this approach, we can actually influence on following factors connected with the green architecture. On the example of our Chico company and our products, I can show you what can be actually approached from every participant in the process of producing and designing glass facades. Chico company, for example, decreased the CO2 emission in 3 years for 60%, with the idea to decrease this for additional 30% until 2025 and to put it on the 0 to 2014. Additionally, we are using much more recyclable materials in our products and also organic products. We find a way to use organic products in our final products. A lot of changes are made in a process of making aluminum constructions or facade construction, because this process is really energy using and really heavy with the CO2 emission. Finally, we participate intensively in the certifications. This is really important, certification of materials, and also participate in the certification of the whole buildings. And finally, management approach, using the softwares which help us to control the whole process of management in an implementation of facades. And I would finish this presentation with the following words. Mayor of New York said that we will introduce legislation to ban those glass and steel skyscrapers that have contributed so much to global warming. They no longer have a place in our city or on our earth. We, like professionals, should do something different. Let's make eco-friendly to be clever, not radical. Clever with having in mind what are potentials on which we can influence and which tools we can find to influence on these potentials. So our mission is to use state-of-the-art technology with a focus with humans and nature. Thank you for your attention.
Well, thank you both. I think it's a really interesting prospect and an interesting view, completely different, I think, and coming from another side of a globe. So I have a question. If you have any question for our speakers. If, okay, so I have one question. As you're coming, well, I will have to say that both of your expertise are somehow coming from the other side, the more professional side. So we have to have already graduated students and already people coming from, you know, with one spectrum of a complexity coming to the industry to be able to deal with all those different things with concrete and all those interesting you know aspects of how to relate it to not only efficiency but this ecological aspect, and also in glass facades, but in glass. But I'm asking, what do you think what do you I will have to rephrase this. What do you need from a person coming as a young professional, coming from the faculty, to be able to and to be, you know, equipped with what in order to start to research and to acknowledge all those things in the industry?
Thank you. Well, as I'm a teacher, also I try to think about that, because there is a big discrepancy between the things that we teach our students and the things that they actually need to know in practice, not only from a designer point of view. And if we think about all these new and innovative technologies, there is a lot of misleading information and marketing that actually gives a false picture about some products or materials. So I think that it is crucial to try to implement like a good methodology for critical thinking, and to equip students with good systematic approaches for example, life cycle assessment, and not only the tools to do that, but the ways how to think about the proper methodology. Because like with statistics, also you can use LCA to get any results that you want. So the boundaries that you introduce are important, and some functional units that you use are important. So I think maybe some broader perspective is really important for our students in order to be good eco builders.
Yeah, eco builders, exactly. Maybe.
Well, first of all, they should learn in university that there is eco dimension in every material, which they will use tomorrow in practice. Then you should they should learn connected with one specific product or material, what I said potentials they can use. Then find the tools how to use these potentials. I think that they're thinking just about design where they're going out from the university. They just lost somewhere every other dimensions. They forgot what they can use. We need to put them on the table, a lot of, I would say, tools. And then they will maybe learn how to play with them and how to put it together in the way which we want and which is good for our surrounding and future.
And do you think that some kind of a practice would be a useful tool that will come during their studies, but not particularly practices to go into the office and work there, but some kind of workshops on and some other kinds of summer schools that will deal with different issues that are not there at the faculty, but can help to widen the perspective of critical thinking and maybe experimentation and things like that, to broaden their views of what is waiting there after the studies.
But first of all, during the university, I think it's necessary to make a contact between practice and university. For example, presentation of people from the practice. That's probably the first step. Second step should be definitely, I'm speaking about materials like a glass facade. The second thing is maybe to think about us. We don't have it in our country, but there is in some other countries specific part of the architectural university which is dedicated to this specific area. How to make a project of the facade. In the world, you have like facade planners. That's specific profession. We don't have it. There is no place where you can learn things connected with the facades here. That's maybe the second idea. And third idea definitely is some summer schools organized by professionals. Those can be some ideas how to connect academical knowledge and practical knowledge and prepare these people, young people, for the working tomorrow.
Well, the answer is definitely yes to that question. I'm just thinking about the difference between my faculty, civil engineering, and the perspective I have on your faculty, the architecture. I feel that you have much more practical work with your student, or something that is similar, or simulation of practical work. We don't have that much space for that at our faculty, which is not a good thing, because we all see our students, for example, when they do their final thesis, most of them started working at that time, and they are so much more mature and so much more interested in the topic that they are researching after only a couple of months in practice. Yeah, so they are regretting all the things that they didn't learn when it was time for that. But also, I'm not sure that at the university we give our students a whole picture of what they can do. We try to teach them to do design, or in theology, to do design or construction or something like that. And there is a lot of different variety of new jobs that they can do, and some of them will. But I don't think that we give them a perspective and show them practically what they can do. So I think it's really important, because I think it's a good market for that now, maybe even better than design.
Okay, so to open a little bit more towards the real world.
To show
Thank you.
To show, to give them the bigger picture. What else they can do besides the simple design.
Yeah, okay, thank you. Some more questions? What? Okay, Emanuela.
How much is important for you the creative dimension brought by students? First, just got this degree and decide to apply for a composition in company. Okay, you prefer to have a person starting from scratch with strong will, intention to learn new things, or on your side, it would be better to have a person which is more, say, confident and skilled, or have more specific interest in some fields?
Well, since I'm working in a, let's say, a private company, I can think about that or answer that from the perspective of Serbian construction industry. Maybe that's not a representative market, but still it's a market. I think that today everything is still in Serbia being built in order to do it fast and as cheap as possible, but to sell as expensive as possible. So in that manner, I think that our professionals actually look for someone who is more experienced, if possible, at the beginning. And that also influences the studies that we designed, because we had some roundtable discussions with the industry to see what are their needs, what they, how they can influence the education system, how can we be better. And the only feedback actually that we got is that we need to introduce more practical softwares, or to teach them as much as possible the practical things, so that they can be, let's say, used quickly to do the job as the best as possible. But I think that new generations are different from my generation, and that they actually are not afraid to start doing something new or to change when they see that the client, the investor, the industry is not good. So I think that it will balance itself out soon, because they will ask for new opportunities and learning new companies.
Well, I'm coming from private company, and your question is $1 million question for us every day, because we are really struggling to find the right people for the area of our business. My personal opinion after many years of experience is that it's not important the previous knowledge. It's important for how open mind is some person by itself, and it needs to be curious to learn. This is for me the most important characteristic of some person. And then next to the people with a lot of experience, they will shape themselves and learn.
Well, thank you.
Yeah, thank you. Actually, I try to by your last answer, like motivation of the person, not important to you from them. Then actually, I don't know what the thing means, but that we don't need some very strict form of previous education that we clear. I do know that it doesn't mean that, but how do we make like that kind of boundary between previous knowledge and motivation and open-mindedness, how to learn open-mindedness? Is there no answer?
How to learn open-minded?
No. Fine. What's the balance between previous knowledge that we actually need and motivation and open-mindedness in our practical career work?
I would say give them a lot of practical work on the university, a lot of essays on specific topics. Let's make young people to need to think in university out of the box, and evaluate this thinking out of the box, but not out of the box without any relation with reality. This is actually where we need to make a balance.
Yes, it's very important.
This question, is the university too late to learn?
Yeah, probably that's the last stage of possibility to learn. Open mind is starting from here, like this.
Yes.
Yeah. But okay, I think that university is still the stage on which they can get this skills. That's skills.
Yeah.
And I have one more, just like a short one. Regarding the ethical standards and regarding the profile of the future, I don't want to say just the architects, civil engineers, the ones for some. Do we need in the future from vertical knowledge, like the specific specialized knowledge, or we need a profile of it's more horizontal, like good or more in detail, my little. Yeah, that is no special knowledge.
But this eco-friendly is the new renaissance. It covers everything.
Very easy question. Well, of course, I don't know the answer to that question, but it seems to me that we need people doing one and doing the other thing, because we cannot all be like strict verticals, and we cannot all be out of the box thinkers, because I don't think that we would finish any job in time if that was the case. So yeah, maybe it sounds like a cliche when I say everybody needs to find their own purpose and what's best for them, but maybe that's what the university should encourage, and the companies should actually look for, to look at the individual, but to know that in the system we need like someone who knows to screw something, and the other one to think about what's coming after that. So balance. How to do that, I don't know, but that seems like the utopia that we
Self-profiling.
That's exactly the right word, self-profiling through the practice. I'm working for a German-Austrian company, and you know, we all think in Serbia that they have the best engineering. But my experience in the last years that they separated this engineering in so small parts, when you need to, you know, answer, which needs to include 3 different topics. That's it. You cannot find a person who will answer you. You will need to collect answers from separate different persons and put it together and try to understand the global picture. So I think that the truth is somewhere in the middle. We need people who knows a little bit of everything, but then specialize people for the specific questions, but through the practice. I would say we need to give people to work, and then to try to put the right people in the right place.
Oh, okay. Thank you. Thank you very much. Do we need a break, a 5-minute break or not? Maybe we can continue, yeah? Okay. Thank you very much. Okay, the last session for today focuses on taxonomy of sustainable design and mainly argues questions of shared strategies for sustainable management of resources in the international level, as well as with the appropriate use of natural and local materials. In this panel session, there are 3 speakers coming from UNIGE with different interests and backgrounds. So the first one, Vittorio Pigigoni, Associate Professor of University of Genoa, where he teaches architectural and urban design. In 2004, he founded the architecture office Bauku. Pigigoni has been a visiting professor at the IIT in Chicago and has lectured in many places, including Columbia University in New York, Architectural Association in London, Cooper Union in New York, Scuola Normale in Pisa. The second speaker, Cristiano Leprati, professor at the University of Genoa for Architectural and Urban Design, DAD, Department of Architecture and Design. He taught at Technische Universität Darmstadt. Then he won an annual DAAD fellowship in Sapienza in 2009, University of Rome, where he was visiting professor in 2011. From 2011 to 2013, as European Director of the International Union of Architects, Architecture for Responsible Future Working Program, he worked to raise awareness in the international community about the relationship between architecture, cities, and the environment. In 2012, he was an official delegate UEA to the United Nations Rio+20 conference in Rio de Janeiro. He has lectures at 22 universities in different countries in Europe, Africa, America, and Asia. He was responsible for the Genoese research unit funded by the European Community for Forget Heritage and Wakening Up the Sleeping Giants. He is currently in charge of the Genoese European Research Unit Climate Lab with a consortium of 9 South American universities. He is currently a board member of a pro-arch scientific society which brings together Italian professors of architectural, urban, interior, and landscape design. As chief designer of the Berlin studio Male Arc, he was a finalist in the competition for the extension of the German parliament and 2011 won the competition for a new city of 30,000 inhabitants on Halong Bay in Vietnam. His main research interest concerns the critical revision of functionalism, understood as a historically determined tradition to be subjected to a process of substantial revision and reconstruction. The research is conducted in the area of a relationship between architectural form and performance. The synthetic theoretization of this research, which focuses on the role of architectural design, is documented in articles and publications. And
Oh, so sorry.
no, it's fine. And the last but not least, Giulia Stola, the architect and a PhD student in architecture at the University of Genoa, DAD, Department of Architecture and Design, focuses her research interests on the history and architectural critiques of the post-war Europe. She held lectures as expert in the field in the classes of Professor Vittorio Pizzigoni and Architectural Studio 1. She combines the theoretical and practical by collaborating with several architectural firms in Liguria. So, please.
Thank you very much, everybody. It's a big pleasure to be here, and thank you, Anna, for your introduction. And yes, first of all, I will speak about sustainability from an architecture, from a design point of view. I'm a professor, but I'm also an architect, and I will. There are many aspects of sustainability, social aspect, an economical one, technical, and also aspects affecting circularity, as we saw today, and or that depends from our habits, as we saw during the pandemic of last years, changing our habits affect also our impact on the environment. But nowadays, today, I will focus on design and how design can help this process. Okay, in looking at design, mostly is very typical that we get, as we saw also today, but in many occasions, many different solutions for small problems, medium problems, large problems involving elements of construction, or houses, or buildings, or sometimes places or cities. But and the sum of all those actions has a huge impact on sustainability of our environment. But on the other scale, design can do something else. Can let's allow us to think big. And at the end, the architecture and architectural design is somehow an instrument developed during the years that allow very precise in visualize a possibility of the future. And this kind of visualization is very common since the very past. For example, the example of Dinocrates that you all know, envisioning to Alexander the Great the possibility of building Monte Athos in the form of himself, of Alexander the Great himself, with a river from one side and a city on the other side. And by the way, the critic of Alexander the Great was a sustainable critic. He asked Dinocrates, where are the fields that providing food for the city? Where is the port, the connection for the trading and the creating the wealth of the city? Dinocrates, by the way, didn't answer those questions, but Alexander the Great was hearing him anyhow, and he built Alexandria and many other cities. But this quality of architectural design, since Dinocrates to Le Corbusier, is always something that very typical of our job, I guess. But on another way, on another side, if there are many occasions in which planning is and was very important for our discipline, nowadays planning a very big scale is not so common anymore. I just take some examples in order to make you remember about the things like the planning of Elberzheimer in US, the new city, or a kind of development of cities that was also related with the possibility of an atomic war, and considering that an atomic disaster could affect as little population as possible. And here is possible. Yes, you can see that. Okay. It's possible to see how a bomb is affecting those points are a kind of living spread out inside the country that is less affected from a nuclear war. Something very typical of that period too. Other kind of planning on a big scale we can find in Italy, for example, in Saverio Muratori work, Civiltà and Territorio, but you can find in each country many different architects that after the Second World War was working on planification of a region, of a nation. And that is just an example of that, what you can think at your country, and I think you can find ideas and proposal of this scale, of a huge scale, of a region, of a nation. Ecology on the other side seems it is difficult nowadays, both for architecture, but mostly for sustainability, to think at this huge scale. But it's something that was very typical for our job. And for example, here we are at the beginning of 19th century, and you see that recognizing the different climate in different parts of the world is something already shared at the time. And something already shared a bit later, 1 century later, is the idea of Buckminster Fuller of a connection between different countries. This is a map of is a map of the world, a bit different from the one we see normally. With the black lines are connection of energy, because the idea of Buckminster Fuller was, yes, come on, if it's night here, the sun is somewhere else, and we can bring energy across our world in order to supply energy from one side to the other. And this idea, Buckminster Fuller developed both at this huge scale, global scale, and in a very small scale of house, like in the Maxion house of 32. And with all those engines, okay, of water consumption and whatever again. But in nowadays, confronting themselves with the sustainability of this huge scale is something that happens very few. And I'm not here to tell you about a solution about that, but just to give you some example and to give you, I think, a direction that should be inside the job of an architect. And for example, I just take 2 examples, so just 1 example. The research developed by OMA AMO in 2010, Europe Roadmap 2050, that divide Europe not in countries, but in potential place for developing different kind of energy. I mean, the scale of solving energetic problem of a nation is different from the scale of solving energetic problem of a house. And we should also work, of course, will be not precise or completely precise, but we should address also this scale of the problem. So the global scale, a world with no energy consumption, with no energy waste, with zero carbon production in the world. And you see, for example, a place where wind energy might be produced easier than he called Solaria, a very big region in which solar energy is much more effective and productive. And for example, a net of connection here, a bigger round circle in North Sea of inside the sea used for wind production, wind energy, and expanding also the boundaries of a country in a region with different resources from a point of view of and thinking about a kind of exchange across the border of nations in winter, for example, as shown in this map, the wind is stronger, so the energy flows in this direction. In summer, the energy produced by solar panel is stronger, and the energy flows in that direction. With nowadays, our connection is very small between countries, because you just supply the energy you cannot produce through oil in your country. And in this envision, you have to strong much more these connections. Of course, those images might be a bit naive, but for me, they give you an an idea, is something that is part of the job of an architect, to give this vision and visualize how will be our life, our city, our nations in the case of we will produce all our energy from sustainable resources. Yes, of course, geothermia and the islands of wind. In 2011, they expanded this vision in the idea of global world analysis. Here is the solar potential map. And it's curious how this map is something very similar to the combination of the map by Mr. Fuller and the one we saw before about the different climate in different parts of the world. Or this kind of connection of energy that flows through continents is very similar to the one of Buckminster Fuller. I don't give you answers, but I think this direction of addressing the problem in his, of course, in its complexity, but in its complexity at this scale, is something that we should work more on. We should invest more time working on a scale that normally is completely out of the radar of our work today. Of course, because there are problems, political problems, economical problems at that stage. But if we should, but that it was always, as we saw, part of architectural job, and I guess it should be also today. How it works? Okay. Buonasera. Thank you for having me. Hope to come back very soon to Belgrade. Thank you for the introduction. It was really very long, but I have to add something. Also to understand my lecture, a little bit more my lecture. I was director of one European program called Architecture for a Sustainable Future, 4 years, by the International Union of Architects. International Union of Architects is an NGO, actually. 124 countries. And I have actually changed a little bit my mind about, or my opinion about sustainability during this time. Because I think, okay, the students, they have to think out of the box, but not out of the reality. But I think nowadays, the meaning is they have to think out of the box, but out of the reality means out of the market. The next picture. Oops, that doesn't look okay. Yeah.
My thought and research on the topic of sustainability began actually 20 years ago in Germany, in Darmstadt, with Günther Pfeiffer. He's a professor and architect from Freiburg, and they are expressed in this monographic book. Unfortunately, or fortunately for you, is only in Italian. But I'm working on a new edition in English. The state of art of my research and the outcomes of my reflection are collected in this book. The thoughts are mainly about the profile of the architect and the relationship between the profile of the architects and the profile of the engineer, and between architecture and construction. The idea of the book is simple, very simple, namely that one aspect of sustainability, the relationship between architectural form and climate, is an integral and essential part of the history of construction and those architecture, obviously, as discipline. But what is meant by the relationship between construction and architecture? The purposes of architecture, according to Aldo Rossi, who wasn't interested in sustainability, actually, are two. First one is create an environment propitious for life through construction, which protects inhabitants from the outside climate, hot, cold, wet, dry, rain, snow. And the other one, the second one, is aesthetic intentionality, the beauty. When there are both, it is possible to talk about architecture. When there is only the first on place, the first one, it's only possible to talk about construction. But what is meant by the relationship between form and climate? Construction is always drawn from, don't worry, I have much more images, and it will take probably about my lecture about 10 minutes or 12. Construction is always drawn from vernacular building patterns. These have adapted to the condition of the context according to a kind of Darwinistic model reiterated by Louis Sullivan in his text on the relationship between form and function, with his reference to the laws of nature, the idea that nature is operating in a functional way. And his refrain on the book, and this is the law, and this is the law, the natural law. Arguing that the relationship between architectural form and climate is an integral and indispensable part of architectural history means that we have no longer to think about equivalent climate problem equal vernacular solutions, and the permanence of form from the vernacular solutions is architecture. Like the case with the temple transition from the wooden to the stone structure. Wooden structure is a vernacular architecture. The stone structure is architecture. And vernacular, vernacular construction. But we have to think in with a different point of view and equivalence between climate problem is equal to architecture itself. to demonstrate this concept, I can start with or no, this is not more interesting. Okay. Bruno Taut, a German architect. The most recent history of the 20th century architecture has addressed sustainability issues in the discussion of hygienism, a crucial theme of urban design in light of the consequences of the urbanization phenomena induced by the Industrial Revolution. The German theories of Licht, Luft und Sonne, light, air, and sun, and the French theories of radius hinge on the theme of hygienism. But in the first decades of the last century, by numbers of masters, the focus architecture masters, the focus is on the design of the individual architectural artifact, determining a mode retrospectively traceable to a kind of proto-environmentalism. Along with the very early Frank Lloyd Wright of a Jacob's House, the number 1, 1937, and the later Le Corbusier of Villa Sharabai, 1956. One of the figures at the forefront of design and theorizing was Bruno Taut. This German master, fleeing Nazism, wrote the book Architekturlehre 1937, which collected his ideas of architecture, emphasizing the centrality of the question of climate as a major factor in morphogenetic processes. Taut, in this book, this is unfortunately only in Turkish, argues that the relationship between architectural form and climate, is an essential fact and highlights a problem of the relationship between architecture and technology. 1937. The text, I'm quoting, I'm just simply quoting Bruno Taut. The sense of proportion must also be applied to the basic concepts of architecture: technique, construction, and function. The theory of architecture can be essentially reduced to the fundamental assertion that architecture comes into existence when we put these basic conditions of architecture in proportion. This means that the proportion of technique consists in the adequacy of the relationship between climate and form of architecture. 1937. That of a construction in the unity of rationality and sensual form, aesthetic intentionality, and that of function in the flexibility of use. Oops. Architectural form cannot be forced into a style. The position of Taut was very critical with the international style, or the style developed or designed by the colleagues. Climate defines the architectural form, and he tried to explain this concept with this kind of sketch. Since climate is everywhere different, the forms of climate architecture can only ever be different. Oops. This is another intelligent way to stress this idea. The proportions are also different. This is the reason why we have not only just one Vitruvian man, but we have different depending from the latitude or the geographical side. Another try to quote Bruno Taut. And this is really interesting because it's dealing with the relationship between architecture and technique. Nowadays, this is a big, an important aspect, I think, also to define our profile as architects and to define the profile of the architects of the future. Technology in the field of architecture wants to equip the house with appliances, protections, special materials, and installations that allow the kind of house to be used anywhere. 1937. Thus, the house is taken out of the hands of the architects and handed over to those of the engineer. The same results are produced as with machines, which everywhere on Earth operate with the same form and characteristics. The result is toward architecture, the international style. The many modern buildings these days are illustrated in architectural magazines. If the place or region where they were built were not indicated under the photographs, no one would be in a position to tell whether they are in Turkey, Germany, French, England, America, Japan, Russia. Oops. Just to refer an example to explain the attitude of Bruno Taut. This is a villa he designed together with Japanese architects Gonkuro Kume in Tokyo, 1936. Combines modern elements. I have another picture, this one. Combining modern elements made possible by new materials such as large, spacious windows and sun protection that replicate the shape of the classical roof with the slight slope and multiple pitches. For the representatives of the new orthodoxy, the international style, the modernist language, this hybrid were unacceptable. Bruno Taut has written in Architettur a lot about the Japanese architecture, because in his opinion, the shape of the Japanese house is entirely determined by the adaptation to the Japanese climate. And that in Japan, the sits on the floor is actually just to enjoy the sunlight as long as possible. Given the geometry of the openings, these aspects add to the fascination of the 20th century architects, which obviously includes Frank Lloyd Wright's for Japanese architecture. The modularism, building system. Okay, I will conclude my my lecture with short statement using, or this guy will help me. His guy is an Egyptian architect, Hassan Fatih. He built a lot for rich people, and with the fees, it support economically housing for poor people. This is one one architecture from Hassan Fatih, and this is the relationship between the movement of the air, the cross ventilation inside of the building, and the shape of the building. It's kind of the architecture in this case is generated by a kind of diagram of the movement of the air inside of the building, like this one. Now we have technologies and softwares which are actually able to simulate the behaviors of the air and water inside of the buildings. And now statement. I think we have to think global and build social, use as a build to improve the quality of life, not necessarily like Hassan Fatih, who built for the rich and to finance homes for the poor, but using technologies that doesn't feed the research market for research, doesn't produce dependence on new materials, but serves to build better than it has always been done, with local materials and a lot of intelligence, perhaps augmented by software support. Thank you for your attention.
So, good afternoon, everyone. First of all, I want to thank you, everyone, to be here, of course, and the University of Belgrade for organizing these days, and all the ECOBUILT partners for today's presentations. During the lifetime of ECOBUILT project, all the partners discussed a lot about what means a sustainable design or eco-friendly design. And today all the lectures explain clearly the complexity of this theme and the different perspective of ecological and sustainability. So the concept of sustainable design can be intended as an holistic strategy in which various aspects of the design process cooperate with the functioning of the project. Technology is an aspect, but also social aspect, environmental and economical ones. The project also works at a different scale, from the internal scale of the house to the scale of a global scale, as Vittorio said. The design strategy holds together different degrees of complexity and multiple steps of the project. And in this vision, history also can give us vision to our present and to imagine our future. And one of the most known architects of the 20th century in Europe used to apply a sort of ecological strategy to their project that is called some sort of proto-ecologism. We are talking, of course, about Le Corbusier, who has been the center of my PhD research during the past 3 years. And I want to stress once more the concept that Le Corbusier has some sort of ecological intuition, and his project since the very beginning of his career, since we can say the years of L'Esprit Nouveau, he writes about the importance of natural elements brought into his project. He revises theory and hygienic design from the 19th century and applies it to his project. He applies some sort of thermal passive control, we can say, studying position and orientation, and also using these two elements to improve lights in his project. It is known that some of his projects are orientated according to cardinal axes, such as Villa Le Lac, where the terrain is chosen for its orientation. This specific site allows the perfect orientation of the house and the perfect functioning. So the house is oriented to receive as much light as possible during the day and have the best visual and contact with the site. Since the years of Verson architecture, he writes about the importance of light, air, and greenery, which should be visible from the inside of each house. He applies the principle that evolves in the one that we nowadays can call biophilic design, which is a strategy that takes into account the spontaneous tendency of human beings to feel good when surrounded by nature. And it is not hard to imagine why, because our brain is made to function best when in a certain natural habitat. And this principle is applied in his urban plans too, where the view from the windows is always directed to natural habitat. And also Le Corbusier tries to bring the new the view of nature inside design, inside the big terraces or basin like in Maison La Roche or Ville Savoie. The importance of nature in his project has been studied by scholars also, which already saw in his 5 points of modern architecture a strategy for dealing with nature and environment and context. And this principle remained during all his career. The connection with nature is so important that when Le Corbusier visits the United States in 1935, he is shocked by the lack of greenery and defines American city as mighty storm, tornadoes, and cataclysm, absolutely devoid of harmony. He writes this book, which is When the Cathedral Were Right. Here he refuses the city planning of American city as New York and Chicago because there is no green in the street. The green is so dense that do not allow the view of natural elements and sometimes not even in the sky. Even skyscraper setback appears to him yet another scam because setbacks give people the illusion of more air and light inside the street, while further elevation only allows more people to cram into cities who will continue to crowd already saturated places. In this book, the anecdote becomes an opportunity for reflection and for design. And for example, when Le Corbusier describes the working day of a typical New Yorker who drives from the station of a small suburb, takes the train or metro and arrives to Manhattan, and then works in the city center, very crowded and full of skyscraper, and then he goes back to the station, takes the train again, and arrives to the suburb, and then back home, very tired. And this repeats every day together with other million people. In this suburb, the typical layout of Garden City, a model that Le Corbusier always supported, is also dismissed. The life of people, their joy and well-being is not considered in the planning of American city, according to him, while it's the center of Le Corbusier's research. So from this scenario, Le Corbusier draws conclusion about planning of the city on spaces, and he gives his judgment on routine housework house, and this is the opportunity to highlight fragility of this routine and offer a different image for the future through a project of new city. In the end, so he proposed his own system of city planning. The project only described, then this is the project of Ville Radios, which is, according to him, the anti-Manhattan, the opposite and chaotic bustle of the metropolis, with its design, its closer anti-urban ideologies, and opposes to the structure of American cities. He proposes his Cartesian skyscraper, which is an improvement of normal skyscraper. It is much bigger and can host more people, allowing many families to abandon the suburb and move to the city. And city is very spacious, and each block is divided by other from a park full of tree and amenities, and nature is brought into houses through large windows. And in 1942, Le Corbusier publishes Maison des Hommes, in which he took up many of these criticisms, updating them. And here he writes once again about the absurd life in Manhattan, where the economy of capitalism created a dense planning. Every piece of land has been sold, and the prices of houses are very unaffordable for people who are forced to live far away and cannot afford what he calls loisir, which is like free time and recreating activities. Life, according to him, is not sustainable, and human well-being should not be subordinate to economics rule. So Le Corbusier here adds an important theme, which is the social theme, which need to be involved when we think of ecological and sustainable architecture. The situation seems to have become even worse. And it is necessary to remind that in 1942, France is under reconstruction and after the Second World War. So according to Le Corbusier, it is necessary to avoid like dormitory city, like suburbs, and they should be as different as possible from the American one. And it is necessary to build for human being. So during the reconstruction of France, among the towns to rebuild, there is also Saint-Dié-des-Vosges, which was bombed and whose historical center was destroyed by fire. So in 1945, a citizens association led by Jean-Jacques Duval asked Le Corbusier to draw up a preliminary plan for reconstruction of the town. The plan totally breaks with the pre-war configuration of the city, as he did in many other plans, of course. He imagines to start from a tabula rasa, where all the standing buildings are demolished. The most innovative part of Le Corbusier's plan for Saint-Dié was the city center, which has a large pedestrian square designed as a focal point for social life of the town that would occupy the land on the north bank of the river. And in this plaza Le Corbusier places the town hall and the prefecture committee rooms and the administrative office. Then Le Corbusier places an administrative tower at a big distance from any other building, and the structures high would have given its occupant a clear view on the entire city. So Le Corbusier designed the tower with heavy sunbreak